myself, Dr. Mrs. R.P. Aditya, Assistant Professor of Mathematics, V.V. Vanniya Perumal College for Women, Virudhunagar. In this video, we will see the definition of sequences, bounded sequences, and various examples related to that. First, the definition of sequences we will see. So, we have to consider a function from set of all natural number to the real number, and we have to define the function f of n equal to an. So, for each natural number, we will get one real number. So, the a1, a2, a3, etc. an is called the sequence in R determined by the function f and is denoted by the set braces, and an will be inside that. So, an is called the nth element of the sequence. The range of the function f, which is a subset of R, is called the range of the sequence. So, we will see various examples related to the sequences. So, first, the function f from n to R given by f of n equal to n determines the sequence 1, 2, 3, etc. This will be denoted by n, the set braces will cover it. So, the next example, the function f from n to R given by f of n equal to n square, which determines the sequence 1, 4, 9, etc. In the third example, f from n to R given by f of n equal to minus 1 the whole power n. So, in this sequence, the first element will be minus 1, the second element will be 1, third will be minus 1, fourth will be 1, and comma, etc. So, in this example, we got to know that the terms of the sequences need not be distinct. Therefore, the range of this sequence is minus 1 and 1. So, thus we see that the range of the sequence may be finite or infinite. If we consider the sequence minus 1 whole power n plus 1, the term will be, first one will be 1 and second will be minus 1, third will be 1 and fourth one will be minus 1, etc. Here also the range of the sequence is plus 1 and minus 1. So, the first sequence starts with minus 1 and this sequence starts with 1. Now, we will consider the constant sequence. So, here also we will consider the function f from n to R and we will define f of n equal to 1. In the place of 1, I can put any constant. So, this determines the sequence called constant sequence. In the sixth example, f from n to R is given by f of n equal to n by 2 if n is even and 1 minus n by 2 if n is odd. So, which determines the sequence 0, 1, minus 1, 2, minus 2, etc. The range of the sequence is z, which is nothing but the set of all integers. The function f from n to R given by f of n equal to n by n plus 1 determines the sequence 1 by 2, 2 by 3, 3 by 4, etc. And if we consider f of n equal to 1 by n, which will determine the sequence 1, 1 by 2, 1 by 3, etc. And in the ninth example, f from n to R given by f of n equal to 2n plus 3. So, if we put n equal to 1, the first term will be 5 and the second term will be 7 and 9, 11, etc. In the 10th example, we are taking an element x from R and f of n is given by x power n minus 1. So, the first term will be 1 and the second term will be x, next x square, etc. This sequence is called geometric sequence. In the 11th example, the sequence minus n is given by minus 1, minus 2, minus 3, etc. The range of the sequence is the set of all negative integers. So, the 12th one is the specific one. So, a sequence can also be described by specifying the first few terms and stating the rule for determining an in terms of the previous terms of the sequence. For example, we are taking a1 and a2 as 1 and an equal to an minus 1 plus an minus 2. So, this relation describes a sequence 1, 1 and we are adding 1 plus 1, we will get 2 and 2 plus 1, 3, 3 plus 2, 5 and so on. This sequence is called the Fibonacci sequence. And in the last example, we are taking a1 as square root of 2 and an plus 1 is root of 2 plus an. So, this defines the sequence root 2, root of 2 plus root 2, etc. So, We have seen the definition of sequences and various examples related to that. Now we will see the definition of bounded sequences. So a sequence an is said to be bounded above if there exists a real number k such that an less than or equal to k for all n. This k is called an upper bound of the sequence. Similarly, a sequence an is said to be bounded below if there exists a real number k such that an greater than or equal to k for all n. This k is called the lower bound of the sequence an. So a sequence is said to be bounded if it is both bounded above and bounded below. So a sequence is said to be bounded if it is both bounded above and bounded below. So these are some remarks related to the definition of bounded sequence. A sequence is said to be bounded if and only if there exists a real number k such that modulus of an less than or equal to k for all n. So we have to define the least upper bound. For that we are going to consider all the upper bounds, and from that we are going to consider the least one, which is called the least upper bound of the sequence, which is denoted by LUB. Similarly, we are going to define greatest lower bound. For that we are going to consider all lower bounds, and from that lower bound we will take the greatest one, which will be denoted by GLB. So we will see some examples related to that. So consider the sequence 1, 1 by 2, 1 by 3, etc. In the sequence, each term is greater than or equal to 0. So 0 is the GLB, and each term is less than or equal to 1. Therefore 1 is the LUB of the sequence. Since the sequence is both bounded above and bounded below, it is a bounded sequence. Consider the sequence 1, 2, 3, etc. Here every term is greater than or equal to 1. So it is bounded above and the GLB is 1, but we cannot find a real number such that this will be less than or equal to k. Hence it is not a bounded above sequence. It is bounded below but not bounded above. So it is not bounded, but it has a GLB which is 1. Consider the sequence -1, -2, etc. Here each term is less than or equal to -1, but we cannot find a number which is such that the sequence greater than or equal to that number. Therefore this sequence is bounded above but not bounded below, and it has the LUB -1. Again consider the sequence 1, -1, 1, -1, etc. Here each term is less than or equal to -1 and greater than or equal to +1. So -1 is the LUB and -1 is the GLB and 1 is the LUB. Since it is both bounded above and bounded below, this sequence is bounded. Any constant sequence, if we consider GLB and LUB are equal to that constant, so that constant sequence is a bounded sequence. So consider these examples. If we consider the sequence 1, 4, 9, etc. Here in the sequence, each term is greater than or equal to 1, but we cannot say it will be less than or equal to some number. So this sequence is bounded below but not bounded above. Hence it is not bounded. If we consider the sequence consisting of set of all integers, it is not bounded above and bounded below. That means we cannot find a number such that every element in the sequence will be less than or equal to or greater than or equal to that number. So set of all integers, it is not bounded above and bounded below. If we consider the sequence 1 by 2, 2 by 3, etc., each term will be greater than or equal to 1 by 2 and less than or equal to 1. So it is both bounded above and bounded below. If it is both bounded above and bounded below, the sequence is bounded. If we consider the sequence 1, 1, 1, we have already seen it is a constant sequence. So it is both bounded above and bounded below, hence it is bounded. If we consider the sequence 5, 7, 9, etc. Here each term will be greater than or equal to 5, but we cannot find a number such that every terms in the sequence will be less than or equal to that one. So it is a bounded below but not bounded above, hence it is not bounded. The last sequence is nothing but the Fibonacci sequence. It is bounded below but not bounded below, hence it is not bounded. Hope you all familiar with the definition of sequences, bounded sequences and various examples related to that. Thank you.